In the first half of Unit 5, we focused on the intersection of two lines, where two lines cross. And we looked at some word problems where there was exactly one way that we could satisfy all of those requirements. What we're going to do in the next two sections is we're going to look at what happens if there's more than one solution. And that can't happen if we're just talking about lines, but that could happen if we're talking about linear inequalities. So today we're going to focus on what is a linear inequality, how do I graph it, what do the solutions look like. So a linear inequality is similar to a linear equation with the exception that instead of an equal sign, there is an inequality symbol. So we're talking greater than or equal to, less than or equal to, just like in Unit 2. A solution of a linear inequality is any ordered pair that makes the inequality true. So any ordered pair that is in a region that line is creating. So to check if an ordered pair is a solution, you're going to plug it in and determine if it's true or false, just like in 5.1 when we checked if a point was a solution by plugging it in and seeing if it was true. Now we're just going to be checking with inequalities. So let's look at some examples of that first. So decide if each is a solution to the inequality. So I'm going to take this point, -2, 4, and I'm going to plug it into this linear inequality, and I'm going to see if I have something that is true or false. So I'm going to plug 4 in for y. I'm going to plug -2 in for x. And I like to put a little question mark here because I don't actually know if 4 is less than -2 times 2 plus 1. I'm not sure if that's true or not yet, so I don't like to say that it's less than if it's not true. So let's see. This is going to become -4 plus 1, which is -3. Is 4 less than -3? No, it's not. So that point is not a solution to this system or to this linear inequality. So let's look at number 2. We're going to ask ourselves, what number are we plugging in for y? And that number is 1. We're going to ask ourselves, what number are we plugging in for x? And that number is 3. Everything else in the equation we're getting from up here is going to stay exactly the same. And then we're going to simplify. Is 1 greater than or equal to -1? Yes, it is. So I'm going to put a smiley face. The answer to this question is yes, that point is a solution to this linear inequality. When I plug that point in, I get something that is true. Go ahead and pause the video and try this last one on your own. Plug that ordered pair in and decide, is it true or false? So 5 is less than 4 plus 1. And that's not going to be true because 5 is not less than 5. 5 is equal to 5. So if this was a less than or equal to, the answer to this question would be yes. But since 5 is not less than 5, the answer to this question is no. That point is not a solution. So in order to check if an ordered pair is a solution to a linear inequality, you're plugging in the x value and the y value from that ordered pair and seeing if the statement that is left is true or false. But what is the solution? What does a linear inequality look like? And what does its solution look like? So a linear inequality is going to look like a line that is graphed, and just like with open circles and closed circles, we're going to have solid lines or dotted lines. And we're going to shade either above or below, depending on the line. And that's what a linear inequality looks like. It looks like a line, sometimes solid, sometimes dotted, that's creating a shaded area. And every solution is in that shaded area for that line. So there are an infinite number of right answers that make this inequality true, but they all fall within a certain region of this line. So if we're going to graph linear inequalities, which is what the next section in our notes are about, we need to first graph the line part just like we did in Unit 4, just like we did in 5.1. So as if there was an equal sign, if it's in slope-intercept, you can identify your slope and your y-intercept. You can plot your y-intercept and go up and over based on your slope. Then you need to ask yourself the question, just like we did in Unit 2 with solid and dotted, with open and closed circles, you're going to ask yourself the question, is it dotted? It's dotted if there's no inequality line underneath, or is it solid? It's solid if there is a line underneath. So graph the line, decide if it's solid or dotted, and then you need to shade. So typically, if it says less than, you're going to shade below, and if it says greater than, you're going to shade above. But the easiest way to make sure you're right is just to pick a point, plug that point in, and see, is that point true? If that point is true, then it should be in the shaded area, so you should shade the side that that point is on. And if that point is not true, then it should not be in the shaded area, and you should shade the other side. So let's go ahead and look at some examples. On number 4, looking at this line, my y-intercept is the point 0, -3. My slope is 2, so I can start at the point 0, -3, and I can go up to right 1, up to right 1. So there I have my points. Now I need to ask myself, is it solid or dotted? And that question is going to be answered looking at this sign. That sign could be equal to, right? It says less than or equal to. So I'm going to make a solid line. I'm going to make sure I have arrows on the ends of my line. Now this is an inequality, so there should be a shaded region, kind of like you see on the graphs on 6 and 7. So I need to figure out, am I supposed to shade above in this region on the left or below in this region on the right? So for me, when I see that less than or equal to symbol, I kind of think I'm probably going to shade down here, but I want to be sure. So what I'm going to do is I'm going to pick a point, and I love to pick the point 0, 0 because I love plugging 0 in. And I'm going to test and see, does 0, 0 actually work when I plug it in? So here we go. 0 less than or equal to 2 times 0 minus 3. Is 0 less than or equal to -3? Well, that's not true, which means this point over here that I graphed should not be in the shaded area, which means I need to shade the other side. So my initial thought was right. So I'm going to just go through and I'm going to just add some shading on this side of the line. And that's my solution. So graph the line by finding the y-intercept and using your slope. Identify if that line is going to be solid or dotted, and then pick a test point. So I'm going to go back and erase this point because that point did not work. So I want to make sure it's not a part of my solution. Let's go ahead and look at number 5. Why don't you pause the video and see how you do on your own. So the slope is -3. The y-intercept is 0, 0. So I'm going to go down 3, left 1, down 3, left 1. This is going to be a dotted line because there is no inequality, or there is no or equal to under this inequality. I still need to have arrows on the ends. And now I can't pick 0, 0 as my tester point right now because 0, 0 is one of the points that I just used to graph this line. So I need to choose any other point. So I'm going to choose, and again, I'm looking at this and this looks to me like it says greater than, which makes me think I'm going to shade this side, which looks like it's above the line. But to be sure, I'm going to pick a tester point. I'm going to pick this point right here because that looks definitely to be on the right of this graph. And that point is 3, 0. So I'm going to test the point 3, 0. So when I do that, y is 0. 0 is greater than -3 times 3. 0 is greater than -9. Well, that is definitely true. It's true, so I'm going to shade the side of the line that that point was on, which is this side over here. Whoops. And that's going to be my solution. So the solution is the graph. And the graph has an infinite number of points that make this inequality true. And that's why we have to graph it to represent the solution. You could never possibly list all of the solutions to an inequality. You could list some, but the graph represents the infinite number of solutions. Okay, the very last thing that we're going to talk about is probably one of the hardest things I think in math in general is what happens if they give us a graph and they're asking us to identify the equation or the inequality. And this is difficult at all levels of math, whether it's an inequality or a different type of graph. With a line, we want to use the things that we know. So we want to identify the slope and a point. any point, then you can use that to write the equation in point-slope form. Or if you can tell what the y-intercept is, you can write it in slope-intercept form. Then, if you can see the above and below, above meaning greater than, below meaning less than, then you're going to guess that sign. And I have guess in quotations here because it's really an educated guess. And then you're going to test a point to confirm that your inequality is right. And if your inequality is wrong, then you need to switch it around. So let's look at two examples here. Looking at number 6, I can see my y-intercept is here. That's at 0, -3. So my b value is -3. I can see another point right here at 0, -1. I'm going to use that to identify my slope. So left to right, I'm going down 2 and to the right 1. Down 2 and to the right 1. So my slope is going to be -2. So y something -2x minus 3. Is my line solid or dotted? It's solid, so there should be an or equal to sign. And to me, it looks like my line is shaded above, so I'm going to guess greater than or equal to. But I'm not sure if this is true yet. So I'm going to pick a point in the shaded region. It's like 0, 0. That's on the shaded side, the brown side. 0, 0 is an answer, is a true solution to this inequality. So when I plug it in, I should get something that's true. So let's check and see if that works in this case. Is 0 greater than or equal to -2 times 0 is 0? Minus 3. Is 0 greater than or equal to -3? Well, is 0 equal to -3? No. Is it greater than -3? Yes. Only one of those two things can be true. So that's going to give me that I was right. If when I tested this point I was wrong, I would just simply flip that inequality sign around and I would have the correct answer. Okay, number 7. Y-intercept looks like it's at +1. Slope looks like it's up 1, right 1. So we're going to have the y. I don't know what the symbol is yet. X, 1x, or just x plus 1. Is the line solid or dotted? It's dotted, so I'm not going to have the line underneath. And it looks like it's shaded above to me, so I'm going to guess above. I'm going to guess greater than, and if I'm wrong, after I test my point, I can just flip my inequality sign around. So I need to pick a point, and I think it's easier to pick a point in the shaded region. I need to pick a point in the shaded region and figure out if that is true. If it's true, then I'm right. If it's false, then I need to switch my inequality sign. So I'm going to pick this point right here. No negative numbers. That point is what? 0, 2. So 2 for y. 0, 2 is true. Look at the graph. 0, 2 is in the shaded area, so it should work. So if it doesn't work in the equation that I just created, and the inequality I just created, then I'm going to need to switch it around. So is 2 greater than 1? Yes, it is. Go us. So this is going to be the solution to our linear inequality, or that's going to be the linear inequality that is graphed in number 7. So let's recap the highlights from these notes. A linear inequality is a line with a shaded region. There's no equal sign on this line. There is an inequality sign, so there is a shaded area. To test if a point is a solution, meaning to test if a point is in that shaded area, you just need to plug it in to the inequality and see if that is true or false. To graph a linear inequality, you're going to graph it as if there was an equal sign, but keeping in mind whether the line should be solid or dotted based on the inequality sign. You're going to pick a test point to shade, to make sure that you shade the correct side of the line based on whether that test point is true or false. Lastly, to write a linear inequality from a graph that's given, you're going to identify the slope and the point just like you would to write the equation of a line from a graph. You're going to make an educated guess on what you think the inequality is based on the image, and then you're going to test a point in the shaded region to see if you're right. If you're right, keep your sign the same. If you're not right, switch your sign around. Looking forward to supporting you with this in class. Thanks for listening.